The song I'm gonna sing, joking, heats the flow of energy due to temperature differences. We're reorganizing the PowerPoints to make it a little easier for you. So if you see highlights, and unfortunately it'll be a green highlight on the yellow print, that's for your notebook. However, we do not grade notebooks, just so you know. So temperature depends on particle movement. We already know all matter is made up of atoms that are moving, and even solid objects have atoms that are vibrating, but they do not change position. The motion from these atoms gives the object energy. The kinetic theory of matter is that all particles that make up matter are constantly in motion. And remember these drawings we saw before. So if it's solid, they're vibrating atoms. They're liquid, they're flowing atoms. And gas, they move freely. We don't talk about plasma very often, but it's a very high energy gaseous state. And they move extremely fast and freely. Here's the important thing. The measure of the average kinetic energy of all the particles in the object is their temperature. There are three ways to measure temperature. Kelvin, which is basically at 0 degrees, you have no energy movement. And at 0 degrees, the reason we use Kelvin is because there are no negative numbers in Kelvin. So when you use it in physics later on or chemistry to do calculations, Kelvin is the preferred method because there's no negative numbers. Celsius has negative numbers. And look at that, at 0 degrees, water freezes, but the Kelvin equivalent is 273.15 Kelvin. So the difference between Celsius and Kelvin is you subtract 273 degrees. It's the same degrees between Celsius and Kelvin. Okay. We don't like to play with Fahrenheit. You might have something that uses Fahrenheit, but Fahrenheit is very unwieldy because it's hard to convert them. So we generally do not use Fahrenheit. Just for your knowledge, water boils at 212, but it's not even like round numbers. 212 Fahrenheit is water boiling, and 32 degrees Fahrenheit is water freezes. Kelvin is much nicer in the way it works out because at 0 degrees you have absolute zero. At minus 273.5 degrees, 0.15 Celsius, you have absolute zero. Fahrenheit, you have like minus 459. At 273 Kelvin, you have water freezing. At 0 degrees Celsius, you have water freezing. 32 Fahrenheit. So this is why we don't really pay attention to Fahrenheit. Temperature is measured in units called degrees. And the important thing to remember is Celsius. Water freezes at 0 and boils at 100. And to convert to Kelvin, you add 273 to the value. How does the thermometer work? It measures temperature because the substance, the liquid inside, will either contract or expand by temperature change. This is known as thermal expansion. All gases, liquids, and most solids expand when their temperature increases. When you're on the road and you hear the bump, 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 bump on the freeway, those are thermal expansion joints on the freeway. They're used to accommodate thermal expansion. When you put the cement on the freeway, you have to put it in certain distances because after a while the heat will make it expand, and so you have to accommodate for the heat expansion of the concrete. And that way you have these little gaps. Whenever you ride on the freeway, you can hear a car go dun 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 every so many feet. Okay, and so these are very short. That's why bridges are built with short segments with small breaks to allow for expansion. If you don't accommodate expansion, the concrete will expand and they'll crack against each other. Energy flows from warm objects to cooler objects. Hot to cold, hot to cold. Sing it with me. Joking. So heat, the flow of energy from an object at a higher temperature to an object at a lower temperature. Thermal energy is the total random kinetic energy of particles in an object. Kinetic energy is defined as energy of motion. So you remember potential energy and kinetic energy? Potential energy was like your stored energy at a certain height. As you drop it and the object moves, that's your kinetic energy. This is all a review, correct? You measure heat by the units of calories and joules. The calorie is the amount of energy needed to raise the temperature of 1 gram of water by 1 degree Celsius. 1 calorie is 4.18 joules. This is not a food calorie. A food calorie is 1,000 calories. So when you look at a Doritos and a Doritos has one chip as 30 calories, that's 30,000 calories, not one single calorie. Okay, so a food calorie is different than a normal 4.18 joules calorie. Some substances change temperature more easily than others. This is known as their specific heat, which is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. You can look at water as being the highest one. It takes the most amount of energy to change. But some things like wet mud, wood, limestone, aluminum, these take less energy to raise the temperature. So the transfer of energy as heat occurs in 3 ways: conduction, convection, and radiation. Conduction is when you move energy from one process to another, one object, through touch. Conductors are materials that transfer energy easily, like wire or anything metal. Insulators are materials that do not transfer energy easily. So that's like paper or things we use to hold a hot object. So, example, the hot cup of cocoa transfers heat energy to cold hand. That's conduction through touch. Convection transfers energy by movement of large number of particles in the same direction within a gas or liquid. Sometimes you refer this to fluids. A fluid is anything that flows, that can be a gas or a liquid. It's normally cyclic in nature, so boiling water and heating of a room is an example of convection. It's moving the gas or the liquid to heat the object. So when you have a boiling pot, it starts with conduction. The fire touches the metal plate. Then the metal plate touches the water molecules. But once the water molecules start to move around inside, that's convection. Density, when you have something dense, mass divided by volume, the cooler things are more dense than hot things. Mass divided by volume. Okay, so if you have something cold, it contracts, it has a smaller volume. It'll be denser than the other object. That will cause it to sink. It flows under the air, and this will push the warm air up. That's convection. It's a circular movement. So as the warmer air rises, it cools and becomes more dense and falls. So this cooling and movement of warmer air creates a cycle of convection. If you have a rapid cycle of convection in nature, it can lead to a storm front, or it can lead to like a tornado as the spinning increases. Radiation is movement of heat through a vacuum. You don't need a molecule to pass it. There's no touching. You don't need a gas or a liquid to move it. There's no touching. Radiation occurs from the sun, sending waves of energy at us. So it normally travels by electromagnetic waves. You have visible light, microwave, infrared. So the radiation from the sun strikes the atoms in your body, and this causes a transfer of energy. This is a very important table that basically sums up everything we talked about. And so this is a very important highlight in your notebook. Notice conduction is energy transferred by contact. Convection is gas and liquids. And radiation is through by electromagnetic waves, visible light, microwaves, and infrared. Remember that energy always flows from warmer to cooler objects. Convection is the movement of large number of particles in the same direction. All objects radiate energy. And then this continues until all object temperatures are equal. So you have a hot thing, it goes from hot to cold, and it stops the heat movement once it's in equilibrium. This equilibrium is called thermal equilibrium, when things are even. A lot of vocabulary. Good thing we have quizzes to test your knowledge. And Mr. Gary's going to call on you and ask you questions. No pressure.